regular factoring, and then we're going to look at something called slant asymptotes. Okay, so let's make this bigger here. Make it so I can write. Okay, all right. So quick review of just factoring regular. If I have something like 12x to the third plus 22x squared minus 20x, what should I do first to factor that? I can pull out an x. Can I pull out anything else with it? I can take a 2 also. So I'm going to take out a 2x, which is going to divide everything by 2 and take an x away from it. So 6x squared plus 11x minus 10 is what I'll have here. Then I'm going to have 6x squared minus 11x minus 10. I've got to try to break that down. This one's one that's this is a little more difficult than a lot of the ones we've done before, because 6x squared, what could I use to get 6x squared? I could use 6x and x. What else could I use? 3x and 2x. So I've got two options for that. Over here for that negative 10, I could use negative 2 and 5. I could use negative 1 and 10, or I could switch to negatives on those. I'm not going to list them, but I could switch to negatives. So I've got a lot of I've got options for my x's and for the second term as well. So I generally use the two closest together first. It just seems like they end up being that more often than not, but not always so. We might have to throw this out in a second. Lucas, which one do you want to try for the 10? Negative 2 and 5 or negative 1 and 10? Okay, that's what I usually do the two closest together for both of these. Just seems that test makers tend to use them more often. So if we check to see if this works, this gives us negative 4x. This gives us, oh, look at this, positive 15x. Does that work? That is 11x. That works. So we factored it correctly on first try. That is beautiful. And so this is our factored version of this. From this, it is much easier to find our zeros than it is if you have the non-factored version. Okay, let's look at number 10. This one is weird. I've got 16 minus 8x plus x squared. It's weird because I got the number first, right? You can either leave it like it is, or in this case, you could rewrite it with the x squared first. Either one. Let's leave it like it is just to see what it looks like. For that, I've got 16 over here. I could use 4 and 4, or 2 and 8, or 1 and 16 for that. Or I could use the negatives, and I'm feeling like I'm probably going to need negatives because I got that negative 8 in the middle, right? So like negative 4 and negative 4, negative 2 and negative 8, negative 4 and negative 16. Right? And then over here, x squared, my last terms will be x for that. So in this case, negative 4 and negative 4 gives me negative 8, so I'd have negative 4 plus x, negative 4 plus x. And then in the bottom, I have a greatest common factor. Those both have x's, so I could factor out x times x squared minus 9, like that. And will that factor any further? X squared minus 9. What's it factor into? X plus 3 and x minus 3. So I could have negative 4 plus x. I could write like this, negative 4 plus x squared, and then x times x minus 3, x plus 3. This is good for finding zeros. It's good for finding vertical asymptotes and holes in the graph. A lot of times we need to be able to factor, right? We've already been doing some of this. I was just throwing a couple other things out there that we maybe haven't looked at a lot. So, one thing in some earlier notes, there was one little note we wrote that there would be a slant asymptote in a certain case. And I said we're going to hold off on talking about that until we get here. And so here is where we are going to talk about the slant asymptote. And slant asymptote is going to happen when the degree of the numerator is exactly 1 greater than the degree of the denominator. Okay, so we've seen vertical asymptotes, we've seen horizontal asymptotes. A slant asymptote is going to be just a straight line, but it's not going to be vertical or horizontal. It's going to be slanted. And as our graph continues, it gets closer and closer and closer to that line, right? These technically on your end behavior are still positive infinity or negative infinity because this keeps going up forever here, right? But it's getting closer and closer to just being linear as you look at it. So we need to be able to find what these slant asymptotes are for graphs. It's part of our curriculum that we're supposed to find. So first of all, we're only going to look for slant asymptotes if our degree of our numerator is exactly 1 greater than the degree of our denominator. Any other thing does not have a slant asymptote. If we have something like x to the 4th minus 3x over x to the 2nd, not a slant asymptote. It's bigger on the top, but it's not a slant asymptote because you have to have the denominator there would have to be x to the 3rd for that to be a slant asymptote. So it's only certain cases that we would look for this anyway. And this is how we are going to find the slant asymptote. So I have x squared plus 7x minus 5 over x minus 2. And so what we want to do, fractions are really just division, right? So what we're going to do is we're going to divide these two. And you do this in Math 3, although I don't know how it went in your Math 3 class. But this was one of the things that we were less successful on in my Math 3 class. There is synthetic division. Do you guys remember doing something called synthetic division? And you you had like a box and you put all these numbers here. We are not going to do synthetic division, although it would work on number 11. The reason I'm not going to teach you synthetic division or reteach you synthetic division is because we have to be able to find slant asymptotes for everything, and synthetic division only works if the bottom is only to the 1st power. So we could use it here, but there's going to be a lot of other questions we cannot use it on, so I don't think it will be worth our time to go back over that. So if we don't use synthetic division, our other option is long division, right? So for long division, let's just do over here to the side. Let's just do a regular long division problem, okay? Let's do something like 278 divided by 4. Let's do 5. I know that won't go evenly. Won't go evenly. 278 divided by 5. So if we're setting up long division for this, right? Because you guys haven't had to do long division by hand in a while, right? What number goes on the outside of the division? 5. So the number on the bottom goes on the outside. Number on the top goes on the inside. So we would say, how many times does 5 go into 2? It does not, right? So we wouldn't put a number there. How many times does 5 go into 27? 5. So we do 5. So we divide. Then we have to multiply. 5 times 5 is 25. Then what do? Subtract. 27 minus 25 is 2. Then bring down that 8. Okay. Then we're going to say, how many times does 5 go into 28? 5 times again. Right? 5 times 5 is 25. We are going to subtract. This time we get 3. So at this point, you have some options on what to do. You can, when you're just beginning this, like when you're lower level grade, you put R3, remainder 3, right? Whenever you get a little bit better at this, you put a decimal and add a 0 and bring that down, and that'll give you the decimal answer. And one thing that I don't know if we do very much in the younger grades, but this is my preferred thing to do, and it's going to help us the most here, is the other thing we can do, our remainder is 3, and the divisor was 5, so we can write it as a fraction, 3/5. Right? Just your remainder over the number you were dividing by. So this is going to be 55 and 3/5. Yeah, you can do decimals, it's fine. For the functions, this fraction is going to be kind of what we want to do. But definitely 0.6, you need to be able to do, well, you're not going to be asked just a regular long division problem on anything we're doing, but you should be able to do both. All right, so let's take that, let's translate it over here to the functions, okay? So we are going to put what's on the bottom goes on the outside, so there's our x minus 2. And then we're going to have x squared plus 7x minus 5. Okay, so dividing is the hard part here. I have to think, so like, it's kind of easy with numbers. You're thinking, how many times does 5 go into 27? Because you can divide that. If I ask you, how many times can x minus 2 squared go into x squared plus 7x? Not as easy to think about, right? Rather than thinking about dividing, here's what I think. I think I need to know what number times x would give me x squared. Or what expression times x would give me x squared. So x times x would give me x squared, right? So that's what I want to put here, x. And we want to put it above the term with the same exponent, right? So so we want to put it, since this is x to the first power, we put it over top of the term that has x to the first power, which we're going to see is always going to be over towards the end for these problems, because they should only have a difference of 1 in their degree, so it should always be over here towards the end. It'll never be over here for these problems. So then, like over here, we got our 5, we multiplied. That's what we're going to do here. So we got to do x times x minus 2. Okay? To do x times x minus 2, we would distribute that x, right? So we would get x squared minus 2x. So right here we're getting x squared minus 2x. Okay, then what do we do next? Subtract. Here's where I usually mess up, and most kids usually mess up, because you are subtracting, which means right here you just subtract, and that should cancel out. That should happen every time. But right here I am subtracting negative 2x. What am I really doing if I'm subtracting negative 2? I'm really adding 2 right here. So I'm going to get positive 9x. It's so easy to get your signs mixed up on this, so be really careful with that. Then we're going to bring down. Everybody good there? Okay. All right, so next step, I'm going to switch colors here. Let's do blue. All right, so next step, we're asking ourselves, what right here could I multiply by x to get 9x? 9, right? And it'll be a positive 9, so I'm going to put plus 9 right there. And then I'm multiplying 9 times x minus 2. So if I distribute there, that's 9x minus 18. So I'll get 9x minus 18 here. Okay, then we need to subtract. We're subtracting 9x minus 9x. That cancels and goes away, which should happen every time if we pick the right number, right? Then I got to do negative 5 minus negative 18, which is really like I'm doing plus 18, right? It's going to be the opposite sign of what you have there. So that's going to give me 13. Now, I can't really do like the decimal version here, right? I can't add things on here for decimals. So what I've got to do is just like my fraction remainder. So for this, I'm going to write f of x equals, I've got x plus 9 plus 13 over x minus 2. Okay, so if I were to like go to Desmos or my calculator and graph this first function and graph the second function, it'd be the exact same graph. These are different ways of writing the same equation, right? We just divided this and it's written in a different way. Now, here is why this is helpful. If you have it written this way, the part that is not a fraction is the equation of your slant asymptote. So my slant asymptote here would be y equals x plus 9 for that.
So really after you get the first number to the top of the long division, you stop?
Yes, yes. So the remainder is really not all that important if it's only asking you for the slant asymptote. You'll also see here, because the degree is always just one bigger on the top than it is on the bottom, you should always just get two terms there, right? When we did long division of polynomials in Math 3, we might do like ones where we would get long strings of answers, right? You won't have that happen here for slant asymptotes because the numerator is always just one degree higher than the denominator. So you should always get like a linear term here. It should be something with an x and then a number by itself right here is what you should get every time. Okay, questions? All right, let's do one more that's a little harder. Actually, I do want to show you real quick. I want to show you what this looks like on Desmos. I know you can't use Desmos, but it helps to picture what's happening here. So my original graph was f of x equals x to the second. Oops. Second plus 7x minus 5 and x minus 2. And zoom out a little bit there. If I graph the second one that I got, x plus 9 plus 13 over x minus 2, notice it's the exact same graph. That lets me know I did it correctly. If we could use Desmos, that would be helpful for us, but we can't. You could, yeah. If it's multiple choice, you could graph the two and see if they're the same. If it's giving you this, if it only gives you the equation of the slant asymptote, you would have to like see if the slant asymptote lines up. And so, if I graph the slant asymptote y equals x plus 9, notice how that right there goes. Like as you go out here, you get closer and closer and closer to that line. That's what this slant asymptote looks like on the graph there. So that green line, that's what we're finding here. Okay. All right, let's do one more, and then we're going to move on for today. I don't know why that keeps popping up. I don't need it. What have I done? Why is it? I don't want that. I want to go back. Okay, I'm going to lose my mind. Why is this in here? Oh. All right, okay. Next slide. Okay, same thing. I know I need to look for a slant asymptote here because my degree on the numerator is one higher than the degree on the denominator. So for this, what goes on the outside here? The bottom. So 2x to the third plus 4x squared plus 3x. And then on the inside, I'm going to have 6x to the fourth minus, oh wait. I would do this right here. Notice how we went from x to the fourth power down to x to the second power? We skipped a place. So I would do this. I'd put 0x to the third right there. Because if you don't, sometimes you won't get things lined up like they need to be. And then we subtract 3x squared plus 2x minus 1. So we're thinking, what times 2x squared would give us 6x to the fourth? All right, I'm sorry. What times 2x to the third would give us 6x to the fourth? what would give us 3x, right? And so since it's just an x, I want to write it way over here above my 2x, right? So I'm going to put my 3x right here. And I'm doing 3x times 2x to the third plus 4x squared plus 3x, which I would just distribute here. And I'm going to get 6x to the fourth plus 12x to the third plus 9x squared. So that goes here. And you can do that part in your head if you want. Notice why it was important that I put that 0x to the third there. If I did not, things wouldn't be lined up correctly. I'd have an x to the third underneath the x squared. So if you're missing a term, if they don't go in descending order, you want to put that blank right there. It will mess you up bad if you don't. All right. And so we need to subtract. Here's where I'm most prone to mistakes. Where 6x to the fourth minus 6x to the fourth is going to go away. That should happen every time. 0x to the third minus 12x to the third is going to be negative 12x to the third. Negative 3x squared minus 9x squared is going to give me negative 12x squared. And then I'm just going to bring down my plus 2x right there. Switch colors now for the next part. Everybody good there?
So is every single like so all the numbers like under the first line of numbers, like the first top numbers of those, are they all automatically negative?
They are in this case because they were all positive, right? If one of these numbers was negative, like if that was a negative 9x squared, subtracting it changes it to a positive.
Yeah.
So when you're doing that subtraction step, it changes the sign of the denominator, or the not the denominator, but the bottom line right there. So we're going to see that happen probably. Well, no, all these are positive, so it just a subtraction here. So now we're going to ask ourselves, we need to know what number times 2 will give us negative 12x to the third. So what times 2 will give us negative? I'm sorry. Just negative 6. Because we already have the x to the third. I read that out wrong when I said it. So we got to do negative 6 times 2x to the third plus 4x squared plus 3x. And so that's negative 12x to the third minus 24x squared minus 18x. So that goes here. Negative 12x to the third minus 24x squared minus 18x. Okay, so your question earlier, Lucas, was, is it always a negative? All of these are negative now, right? So when I subtract negative 12 minus negative 12, that actually just turns it to a positive. I've got a positive and negative. Those cancel out. Right here, I'm subtracting negative 24, so that really is like I'm adding 24. And then right here, I'm subtracting that negative 18, so it's like I'm adding. So it changes the sign of whatever you have there. So negative 12 plus 24 will give me 12x squared. And 2 plus 18 will give me 20x. Now, can I divide? I mean, I can bring down, I do need to bring down that negative 1 right there. Can I divide any further? Is something times 2x to the third going to give me 12x to the second? It will not without using negative exponents, and we don't want to do that. So all of this stuff is your remainder. Now, as Lucas pointed out earlier, you really could have stopped once you got that negative 6 if it just asked for slant asymptote, because we got 3x minus 6 plus 12x squared plus 20x minus 1 over what you were dividing by, which is 2x to the third plus 4x squared plus 3x, right? But for slant asymptotes, all I need is this first part that's not a fraction, right? So if I didn't even find the remainder for this part, I could still get the slant asymptote for that. So my slant asymptote would be y equals 3x minus 6. Okay, questions? Okay. The second part of the Delta Math has some of these questions on them. I'm not going to require that because you'll be doing some of these on that quiz, so you'll get some practice with them there. If you want some practice with them, you can go back and do the Delta Math for some practice, but I'm not going to assign it as an assignment to you guys.